Hello, students. Welcome to all of you in FFB Live Chemistry class. आज तुम लोगों को इस ब्लॉक एलिमेंट्स के बारे में जो थोड़ा बहुत बाकी रह गया है उसी पे हम डिस्कस करेंगे। इस ब्लॉक एलिमेंट्स में कंप्लीट स्टडी कर चुके हो तुम लोग फर्स्ट ग्रुप एलिमेंट्स की, और उसके बाद जो है उनके इम्पॉर्टेंट कंपाउंड्स, जो इम्पॉर्टेंट एलिमेंट थे फर्स्ट ग्रुप में, जैसे कि सोडियम के इम्पॉर्टेंट कंपाउंड्स पे हमने डिस्कस किया। उसके बाद सेकंड ग्रुप में कैल्शियम के इम्पॉर्टेंट कंपाउंड्स पे डिस्कस किया, और उससे पहले के क्लास में हमने एल्कली मेटल्स और एल्कलाइन अर्थ मेटल के बारे में कंप्लीट केमिस्ट्री उनकी तुम लोगों को बताई है। तो आज के क्लास में हम जो फर्स्ट मेंबर हैं फर्स्ट और सेकंड ग्रुप के, वो अपने ग्रुप के अन्य मेंबर से थोड़ा डिफरेंट बिहेवियर शो करते हैं उनके बारे में, जिससे कि इसे कहा जाता है कि एबनॉर्मल बिहेवियर ऑफ एलिमेंट्स ऑफ फर्स्ट एंड सेकंड ग्रुप। तो उस पर हम डिस्कस करेंगे। इसके अलावा इम्पोर्टेंस ऑफ सम एल्कली मेटल्स एंड एल्कलाइन मेटल्स पे भी हम डिस्कस करेंगे। कनेक्शन में प्रॉब्लम आ रही है, तो वेट करो थोड़ी देर। जैसे ही कनेक्ट हो जाता है हम बताएंगे। आज थोड़ा क्लाउडी वेदर है, जिसकी वजह से नेट काफ़ी स्लो चल रहा है, और यही रीज़न है कि जो हमारे डॉक्यूमेंट्स हैं वो खुलने में थोड़ा प्रॉब्लम हो रही है। तो सॉरी फॉर द इंटरप्शन, बट फाइनली ओपन हो गया है, और अब हम अपने क्लास का टॉपिक स्टार्ट करेंगे। today's topic is abnormal behavior of lithium in the first group with the first group elements and the abnormal behavior of beryllium with the other members of the second group, and also the importance of alkali metals, some alkali metals and alkaline metals. These are the topics for new topic as per example. Importance of some alkali and alkaline earth metals like potassium, sodium, magnesium, and calcium, and abnormal behavior of lithium and beryllium metals of S block of the periodic table. The chemistry of S block elements plays an important role in sodium, potassium, calcium, magnesium, or etc. Have a physical importance for both animals and plants. Many useful chemicals such as sodium chloride, sodium hydroxide, sodium carbonate, potassium iodide, bleaching powder, lime, cement, plaster of Paris, etc., are obtained either from natural sources directly or produced from compounds of these elements. The production and consumption pattern of these compounds is an index for the nation's prosperity. The group first day of the periodic table consists of six elements, as you know: lithium, sodium, potassium, rubidium, cesium, and francium, beside hydrogen. Hydrogen is the first member of S block elements. और प्रीवियस स्टडी में तुमने पढ़ा था कि इसको दोनों ग्रुप यानी फर्स्ट और सेकंड के बीच में रखा गया है विद द कार्बन एटम. These elements are collectively called, except hydrogen, S block first A group elements are collectively called as alkali metal group metals, and group first A is known as alkali group as the hydrides, as the hydroxide of these metals are soluble in water and these solutions are highly alkaline in nature. The word alkali has been derived from Arabic word alkali, meaning the ashes of plants from which compounds of sodium and potassium were first isolated. Now use of alkali metals and other compounds. Sodium and its compounds के बारे में हम डिस्कस कर चुके हैं और उनका यूज भी बता चुके हैं. Second is potassium and its compounds. The important uses are potassium is used in photoelectric cell, and alloy of potassium and sodium is used in special thermometers employed for measuring high temperatures. This alloy is also used in nuclear power plant for heat transfer. The potassium chloride is used as fertilizer. Potassium superoxide, that is KO2, is used as oxidizing agent and air purifier in space capsules, submarines, and breathing mask. Potassium iodide is used as a solvent of iodine as medicine and laboratory reagent. It is also used in photography. Potassium carbonate is used for making glass and ceramics. The mixture of potassium carbonate and sodium carbonate is used as a fusion mixture. Now, potassium hydroxide is used in the manufacture of soft soaps. It is an excellent gas absorber. The potassium nitrate is used the ceramic colored TV tubes and fluorescent light tubes. Cesium is used in photoelectric cell. Now, biological importance of sodium and potassium. Both sodium and potassium ions are essential constituents of biological fluids. It is observed that a human being weighing about 70 kg contains about 90 gram of sodium and 170 gram of potassium, respectively. Though sodium and potassium ions are quite similar chemically, but they differ greatly in their biological activities. Their distribution in biological system is also different. The potassium ion are present in higher concentration inside the cell, while sodium ions are present in higher concentration outside the cell. Sodium ions are primarily found in blood plasma and interstitial fluid which surround the cell. These ions participate in the transmission of nerve signal in regulating the flow of water across cell membrane and in the transport of sugars and amino acid into cell. Potassium ions, which are abundant within cell fluids, activate many enzymes which are responsible for oxidation of glucose to produce ATP, that is adenosine triphosphate. There is a considerable variation in the concentration of sodium ion and potassium ion found on the opposite sides of all cell membranes. The cation's gradient control the development and functioning of the nerve cell. These ionic gradients called the sodium potassium pump operate across the cell membrane. The energy of this operation is provided by hydrolysis of energy rich molecules ATP. Both sodium and potassium ions are essential ions for living organisms. The daily requirement of sodium and potassium is about 2 gram each. Now come on the abnormal behavior of lithium. Lithium is the first member of alkali metals. It being the first member of alkali groups exhibit the characteristic properties of alkali metals, but it differs at the same time in many respects from them. Reason for this anomalous behavior is mainly due to small size of the lithium atom and the lithium ion. Lithium ion, on account of its small size, exert the greatest polarizing effect. But polarizing effect out of all the alkali metals ion on a negative ions. Consequently, covalent character is developed. Lithium has the highest ionization energy and electronegativity as compared to other alkali metals. Now, lithium differs from alkali metals in the following respects. First, it is more harder and lighter than other alkali metals. It is not affected by air easily and does not lose its luster even on melting. Lithium reacts slowly with water to liberate hydrogen, while the other alkali metals strongly reacts with water to liberate hydrogen. It does not react with oxygen below 0 degrees centigrade. When burned in air or oxygen, it forms only monoxide, that is lithium oxide. However, the rest of the alkali metals give peroxide or superoxide. Lithium oxide is much less basic than oxides of other alkali metals. Lithium is the only alkali metals which directly react with nitrogen to form lithium nitride Li3N. Lithium hydroxide decomposes at red heat to form Li2O. Hydroxides of other alkali metals do not decompose. लिथियम हाइड्रोक्साइड डिकम्पोज होकर लिथियम ऑक्साइड देता है, जबकि दूसरे एल्कली मेटल ऐसा नहीं करते. लिथियम बाई कार्बोनेट is known in solution but not in solid state, while the bicarbonates of other alkali metals are known in solid state. Dilithium carbonate is less stable as it decomposes on heating. to give lithium oxide and carbon dioxide. The other carbonates of alkali metals are stable. Lithium nitrate on heating gives a mixture of nitrite and oxygen, while nitrates of rest of the alkali metals eat only oxygen. This is the difference. LiNO3 on heating gives Li2O plus NO2 plus O2, but sodium nitrate on heating gives sodium nitrite and oxygen. Lithium sulfate is only alkali metal sulfate which does not form double salt, that is Lm. Lithium reacts with bromine very slowly, other alkali metals react violently. Lithium fluoride, lithium phosphate, this is lithium fluoride, lithium phosphate, lithium oxalate, lithium carbonate, etc. are sparingly soluble in water. The corresponding salts of other alkali metals are freely soluble in water. These are not strongly, this is sparingly soluble in water. यानी कम soluble होता है, जबकि दूसरे जो इस तरह के कंपाउंड हैं दूसरे एल्कली मेटल्स के, वो क्या होते हैं, फ्रीली soluble in water होते हैं. Lithium chloride is highly deliquescent and soluble in alcohol and beryllium. LiCl separate out from aqueous solution as hydrated crystal like LiCl.2H2O. Various chlorides of other alkali metals are insoluble in organic solvents and do not form hydrated crystals under ordinary temperature. Lithium, when heated in NH3, forms amides, Li2NH, while other alkali metals form amides like MnNH2. Lithium hydroxide is much weaker base than NaOH and KOH. Now, diagonal relationship similarities with magnesium. The अगले ग्रुप के किसी ग्रुप से पहले ग्रुप का एलिमेंट सिमिलरिटी शो करता है तो इसको कहते हैं डाइगोनल रिलेशनशिप. तो बेरिलियम यहाँ पे सिमिलरिटी शो करता है सेकेंड ग्रुप के मैग्नीशियम से. Now lithium shows resemblance with magnesium on element of group second. This resemblance is termed as diagonal relationship. इस तरह से ग्रुप फर्स्ट में है ये लिथियम, उसके बाद सोडियम, तो इससे कम सिमिलरिटी शो करते हुए दूसरे ग्रुप के दूसरे एलिमेंट के साथ ये सिमिलरिटी शो करता है इस तरह से, जो कि ट्राइगोनली सामने है. तो इस रिलेशनशिप को कहते हैं डाइगोनल. डाइगोनली सामने है तो इसे कहते हैं डाइगोनल relationship. Reason for the diagonal relationships are the following. First, electronegativities of lithium and magnesium are quite comparable. Lithium की 1 है जबकि magnesium की 1.2. Atomic radii and ionic radii of lithium and magnesium are not very much different. Atomic radii of lithium is 1.23 and magnesium 1.33. These are near about. And ionic radii of lithium ion is 0.60 and magnesium ion is 0.65 angstrom. Third, atomic volume of lithium and magnesium are quite similar. Both have high polarizing power. Polarizing power is equal to ionic charge upon ionic radius होता है. Cations with large ionic potential or polarizing power have a tendency to polarize the anions and to give partial covalent character to compound. Lithium resembles magnesium in the following respects. Both lithium and magnesium are harder and have higher melting points than the other metals in their respective groups. Lithium, like magnesium, decomposes water slowly to liberate hydrogen. तो ये रिएक्शन दोनों में स्लो होता है. लिथियम रिएक्ट्स विद वाटर इन स्लो, दोनों रिएक्शन स्लो होते हैं. लिथियम हाइड्रोक्साइड प्लस हाइड्रोजन लिबरेट होती है. इधर मैग्नीशियम का रिएक्शन होता है तो मैग्नीशियम हाइड्रोक्साइड और हाइड्रोजन रिप्लेस होती है. Both the elements combine with the nitrogen on heating. Uh, Lithium combines with nitrogen to form lithium nitride, and magnesium combined with nitrogen on heating to form magnesium nitride. Both the nitrides are decomposed by water with evolution of ammonia. दोनों में रिएक्शन सेम होता है. लिथियम नाइट्राइड रिएक्ट्स विद वाटर टू फॉर्म लिथियम हाइड्रोक्साइड एंड अमोनिया. मैग्नीशियम नाइट्राइड reacts with water to form magnesium hydroxide and ammonia. The reaction in both is same. Both lithium and magnesium combine with carbon on heating to give carbide. Like C2H2. Lithium reacts with carbide to form lithium carbide, and magnesium reacts to carbon, this is carbon, and form magnesium carbides. And carbides yield C2H2 with water. इनका रिएक्शन जब वाटर से कराते हैं तो एसिटिलीन मिलता है. Lithium forms only monoxide when heated in oxygen. Magnesium also form the monooxide like this Li2O and MgO2 react to form 2MgO magnesium oxide. Both oxides are less soluble in water. Hydroxides of lithium and magnesium are weak base and are slightly soluble in water. Both decomposes on heating, composed to give magnesium oxide and lithium oxide and water. Lithium fluoride, phosphate, oxalate, and carbonate, like the corresponding salt of magnesium, are sparingly soluble in water. Carbonates of lithium, magnesium decompose on heating to give lithium oxide and carbon dioxide. Like this, magnesium carbonate on heating decomposes to magnesium oxide and carbon dioxide. Nitrates of lithium and magnesium decompose on heating, giving mixture of nitrogen dioxide and oxygen. Lithium nitrate gives lithium oxide, nitrogen dioxide and oxygen. Like this, magnesium nitrate on heating to decompose to give magnesium oxide, ammonium nitrite and O2. The chlorides of both lithium and magnesium are deliquescent and soluble in alcohol and pyridine. Lithium chloride, like magnesium chloride, separate out from solution as hydrated crystal like LiCl 0.2H2O and magnesium chloride 0.6H2O. Lithium sulfate, like magnesium sulfate, does not form double sulfate, that is L. The bicarbonates of lithium and magnesium do not exist in solid state, they exist in solution only. Lithium salts like magnesium salt undergoes hydrolysis. Alkalis of lithium and magnesium are soluble in organic solvent. अब कुछ पॉइंट्स को समझने के लिए यहाँ थोड़ा एक क्वेश्चन है. एक्सप्लेन द फॉलोइंग. Alkali metals do not occur free in nature. Why? Alkali metals are good reducing agent. Alkali metals are impart color to the flame. Sodium is kept under kerosene and potassium and cesium are used in photoelectric cell. तो explain करता है इसको. First, alkali metals do not occur free in nature. Since the ionization potential value of alkali metals are low, they are very reactive in nature. They readily combine with oxygen, moisture, and CO2 of the atmosphere and many other substances, hence they do not occur free in nature. Second is alkali metals are good reducing agent. Alkali metal act as strong reducing agent because they can lose valency electron easily on account of low ionization potential value and high value of oxidation potential. तो ये सारी चीजें पढ़ चुके हो पहले, फिर भी थर्ड क्या है, फ्लेम वाला क्वेश्चन है. Alkali metal salts impart color to the flame. El- the energy of the flame causes an excitation of the outermost electron, which on return to its original position give out energy to absorb in the visible region. The amount of energy released increase from lithium ion to cesium ion. Thus, the frequency of light emitted increase in according with the formula H is equal to H nu. The frequency of light is minimum in lithium, which corresponds to red light. Now, sodium is highly electropositive and is very reactive. It readily combined with oxygen, moisture, and carbon dioxide of atmosphere. Hence, it always kept in kerosene as to prevent the action of atmosphere. यही क्वेश्चन था कि क्यों सोडियम को केरोसिन ऑयल में रखते हैं. अब क्या है, लास्ट क्वेश्चन क्या था, पोटेशियम एंड सीजियम आर यूज इन फोटो इलेक्ट्रिक सेल. वाई, इस पे आ जाते हैं. बिकॉज ऑफ लो आयनाइजेशन पोटेंशियल पोटेशियम एंड सीजियम आर यूज इन फोटो इलेक्ट्रिक सेल. द लो एनर्जी photons can eject electrons for their metal surface. Now, anomalous behavior of beryllium. This is the second group member. Beryllium differs from rest of the alkaline earth metal on account of its small atomic size, high electronegativity, and slight difference in electronic configuration. Beryllium ion is very small. It exerts a high polarizing effect on any anion associated with it. On account of this, beryllium compounds show covalent character. Its compounds have low melting points and are soluble in organic solvents. These are hydrolyzed in water. Now, main points of difference with other alkaline earth metal is as. First, it is the hardest of all alkaline earth metals. Beryllium is the hardest of all alkaline earth metals. This is due to the fact that maximum metallic bonding is present on account of smallest size amongst alkaline earth metals. Second, the melting and boiling points of the beryllium are the highest. This is also due to maximum metallic bonding. Third is it is not affected by atmosphere. Beryllium is least reactive as its ionization potential is high. However, it does not react with oxygen and nitrogen at high temperature. It does not decompose water. This is due to low value of oxidation potential. It has the tendency to form covalent compounds. The polarizing effect of beryllium ion is high due to its high charge density. The large distortion of electron cloud of the anion brings covalent character. Beryllium has high value of electronegativity, and when it reacts with another element, the electronegativity difference is not so large and the bond is therefore covalent. Sixth point is it does not react directly with hydrogen. Beryllium hydride can, however, be formed by reducing beryllium chloride with lithium aluminium hydride. Beryllium hydride is a covalent compound. It is polymeric solid, that is BeH2 whole N. तो ये इस N मीन्स कि कई मॉलिक्यूल जो है आपस में जोड़ जाते हैं और पॉलीमेरिक स्ट्रक्चर बनाते हैं. It contains hydrogen bridge between beryllium ions. The hydrides of calcium, strontium, and barium are largely ionic due to greater electropositive character. Now beryllium dissolved in alkali with evolution of hydrogen. इसको जब डिजॉल्व करते हैं तो ये बनाता है सोडियम बेरिलेट Na2BeO2.2H2O प्लस हाइड्रोजन लिबरेट होती है. द अदर एल्कलाइन अर्थ मेटल डू नॉट reacts with alkalis like this. It does not liberate hydrogen from acid readily. It is due to the fact that beryllium has lowest oxidation potential among alkaline earth metal. Now, its oxide is amphoteric in nature. Beryllium is thus weak electropositive in nature, then its oxide is amphoteric in nature, that is BeO reacts with sulfuric acid to form beryllium sulfate and hydrogen water, and it reacts with also reacts with NaOH. तो यानी एसिड और बेस से दोनों से ये रिएक्शन करके कंपाउंड बनाती है, तो इस तरह के नेचर को कहते हैं एम्फोटेरिक नेचर. ये बनता है सोडियम बेरिलेट Na2PeO2 plus H2O. The oxide is sparingly soluble in water as it has high degree of covalency. It has high melting point, approx 25 degrees centigrade. The high melting point of beryllium oxide is due to its polymeric structure. Polymetric structure means वो जो है मॉलिक्यूल आपस में जोड़ करके कई मॉलिक्यूल आपस में जोड़ करके पॉलीमेरिक स्ट्रक्चर बनाते हैं. The oxides of other alkaline metals are basic, soluble, and ionic in nature. The basic nature increase in moving down the group. Beryllium oxide has 4:4 zinc sulfide woodside structure, but all others have 6:6 sodium chloride structure. इसके बारे में सेकेंड ईयर में पढ़ोगे सॉलिड स्टेट में. Now, its hydroxide is amphoteric in nature. Beryllium is thus weak electropositive in nature. तो दोनों ही से रिएक्शन करती है बेरिलियम हाइड्रोक्साइड भी, लाइक बेरिलियम ऑक्साइड की तरह एसिड से भी और बेस से भी. तो बेरिलियम हाइड्रोक्साइड reacts with HCl to form beryllium chloride and water, and beryllium hydroxide also react with base NaOH to form Na2BeO2 plus water. The hydroxide is insoluble in water. It is covalent in nature. The hydroxide of other alkali metals are basic, ionic, and their solubility increases on moving from magnesium hydroxide to barium hydroxide. Its carbide Be2C on hydrolysis evolves methane. Be2C and beryllium carbide when reacts with hydrogen to form beryllium hydroxide and organic compound methane. The carbides of other alkaline earth metals evolves acetylene or on hydrolysis. Its carbonate BeCO3 is not stable towards heat. The instability is due to a strong polarizing effect of Be2 plus ion on the large carbonate ion. Its nitrides Be3N2 is volatile. Be3N2 is covalent while nitrides of other alkaline earth metals are ionic crystalline compound. Now its sulfate is soluble in water. It is due to high degree of solvation of small beryllium ion. Beryllium chloride is a covalent compound. It does not conduct electricity in fused state. It is soluble in organic solvent and acts as a Lewis acid. It fumes in air. The chlorides of other alkaline earth metals are ionic and good conductors of electricity in fused state in the solution. Now passive it is rendered passive by concentrated nitric acid. Nitric acid is an oxidizing agent. It forms unreactive thin layer of oxide on its surface and make the metal passive. Its compounds do not impart any color to flame. Very high energy is required to excite electron from lowest energy shell. Its salt can never have more than 4 molecules of water after crystallization, as it has only 4 available orbitals in valency shell. बेरिलियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन होता है 1s2 और इसके बीच हाइब्रिडाइजेशन होता है इस तरह से एस और पी यानी sp3 हाइब्रिडाइजेशन होता है तो 4 हाइड्रोजन मॉलिक्यूल इसके साथ एकोमोडेट हो सकते हैं. अदर एल्कलाइन अर्थ मेटल्स कैन एक्सटेंड देयर कोऑर्डिनेशन नंबर टू 6 बाय यूजिंग डी ऑर्बिटल्स, क्योंकि बेरिलियम के पास डी ऑर्बिटल नहीं होती है, सिर्फ एस एंड पी ऑर्बिटल ही होती है. It has a strong tendency to form complex compounds. Beryllium ion, on account of its small size, forms stable complexes such as BeF3 whole minus or BeF4 2 minus. It forms many chelate-like complexes, especially with oxygen donor. Now, similarities or diagonal relationship between beryllium and aluminium. Beryllium shows some similarities in properties with aluminium, the second typical element of the group third, next group in the Mendeleev periodic table of the next higher period. This type of relationship between diagonally placed element is called diagonal relationship. पिछले लिथियम के केस में भी अभी बताया. Now, this is the one of the characteristics of Mendeleev periodic table. तो इस तरह से ये सेकंड पीरियड में है बेरिलियम बोरान, थर्ड पीरियड में मैग्नीशियम बेरिलियम, ग्रुप सेकंड में बेरिलियम मैग्नीशियम कैल्शियम ये एलिमेंट होते हैं, ग्रुप थर्ड में है बोरान एल्युमिनियम और आगे के एलिमेंट्स हैं. तो बेरिलियम यहाँ पे मैग्नीशियम से कम सिमिलरिटीज रखते हुए सेकंड थर्ड ए ग्रुप के जो का सेकंड एलिमेंट है यानी डायगोनली सामने है उससे सिमिलरिटीज रखता है. और ये जो कैरेक्टरिस्टिक है ये कहलाती है डायगोनल रिलेशनशिप. The following are the cause of diagonal relationship. The polarizing power of beryllium and aluminum ion is high. Consequently, the compounds develop covalent nature. The second point, the standard oxidation potential values of both the elements are very close to each other. The electronegativity values of both the elements are same. The similarities in properties are listed as in nature. Both the elements occur together in the mineral beryl, that is 3BeO.8 to 3.6 SiO2. Both are not affected by atmosphere. They do not decompose water. Both become passive when treated with concentrated sulfuric acid. Both dissolve in caustic alkalis, liberating hydrogen. Beryllium reacts with sodium hydroxide to form Na2BeO2 plus hydrogen, and aluminum reacts with sodium hydroxide and H2O to form sodium meta aluminate. This is sodium berylate plus 3H2. Both beryllium oxide and aluminum oxide are amphoteric in nature, and because these both are react with acid and base. Beryllium oxide reacts with acid and base and form with sodium hydroxide it forms Na2BeO2, and with H2SO4 it forms barium sulfate. Aluminium reacts with HCl to form aluminum chloride and water, and with NaOH it forms sodium meta aluminate and water. Oxides are extremely hard, non-volatile, and have high melting points. The hydroxides are also amphoteric in nature because both are reacts with acid and base. Beryllium hydroxide to form barium chloride with acid, and with base it forms Na2BeO2 plus H2O. Like this, aluminum hydroxide reacts with acid to form aluminum chloride and water, and reacts with NaOH to form sodium aluminum metaluminate plus water. The hydroxide are insoluble in water and decompose on heating into corresponding oxides. हीट करने पे दोनों ऑक्साइड में कन्वर्ट होते हैं और वाटर लिबरेट करते हैं. Beryllium carbide and aluminum carbide Al4C3 and Be2C both evolve methane on treatment with water. Beryllium carbide reacts with water to form BeO and methane, and aluminum carbide reacts with water to form aluminum oxide and methane. Both the metals react with halogens and form halides. Chloride can also be formed in silver in similar way. Beryllium oxide plus carbon plus chlorine to form beryllium chloride and carbon monoxide. Aluminium reacts with carbon and chlorine to form aluminum chloride and carbon monoxide. The halides, except fluorides, are covalent in nature. They have low melting points and are hydrolyzed by water. They dissolve in organic solvent and fumes in moist air. The halides behave as Lewis acid. Beryllium and aluminium both forms polymeric covalent hydrides, both combined with nitrogen when strongly heated in its atmosphere. Like this. हीट करते हैं दोनों को तो बेरिलियम नाइट्राइड और एल्युमिनियम नाइट्राइड बनाती है नाइट्रोजन से रिएक्शन करके. Nitrides on action with water evolve ammonia. Beryllium nitride reacts with water to form beryllium hydroxide and ammonia. And aluminum nitride reacts with water to form aluminum hydroxide and ammonia. Both the metals are obtained by electrolysis of their fused salt in the presence of fluorides. Beryllium and aluminum ions have a strong tendency to form chelate type compounds. Both form fluoride complexes like BeF2 minus and AlF6 minus respectively. The carbonates of both are the are carbonates of both the metals are unstable. Both the ions gives hydrated ions in solution like BeH2O4 2 plus and AlH2O6 plus respectively. The salts of both Be and aluminum do not impart a color to the flame when heated in it. Now, biological importance of magnesium and calcium, or biological importance of some alkaline earth metals, so especially magnesium and calcium. An adult body contains about 25 gram of magnesium and 1200 gram of calcium. Magnesium ions are concentrated in animal cells and calcium ions are concentrated in body fluid outside the cell in the same way as calcium. Ions concentrate in potassium ion concentrate inside the cell and sodium ion outside the cell. Magnesium serve as a variety of function in metabolic process and nerve action. All enzymes that utilize ATP in phosphate transfer requires magnesium as the cofactor. The recommended daily intake of magnesium for adults is 350 milligram. In plant life, magnesium plays a critical role in photosynthesis, the process by which plants convert carbon dioxide and water into sugars. The magnesium is present in the green pigment chlorophyll, which is necessary for the capture of energy from sunlight. Solar energy is the energy source for reaction of photosynthesis. Calcium is essential to all living matter. About 99% of it is in the bones and teeth, principally as the mineral hydroxyapatite, that is CA5PO4 whole thrice OH. The other 1% is involved in several processes: clotting of blood, maintenance of a regular heartbeat, proper functioning of nerve and muscles, and various aspects of metabolism. The calcium concentration in plasma is regulated at about 100 milligram per liter. It is maintained by two hormones, calcitonin and parathyroid hormone. It is important to know that bone is not an inert and unchanging substance, but it is continuously being sublished, solubilized, and deposited. That bone is not an inert and unchanging substance, but is continuously being solubilized and redeposited to the extent of 400 milligram per day in man. All this calcium pass through the plasma. Children requires an adequate daily intake of calcium for the proper development of teeth and bones. Adults, especially older women, requires calcium to prevent osteoporosis, a condition in which the bones become porous, brittle, and are easily broken. The recommended daily intake of calcium for adult is 1200 milligram. तो ये तुम्हारा जो एस ब्लॉक एलिमेंट की स्टडी थी ये ख़त्म हुई। तो ये स्टडी तुम कर कहाँ रहे हो? माय यूट्यूब चैनल FFB लाइव केमिस्ट्री क्लास 11th एंड 12th। तो प्लीज़ सब्सक्राइब दिस चैनल एंड और अपनी स्टडी को इसी तरह से जारी रखो। तो ये एस ब्लॉक एलिमेंट्स चैप्टर तुम्हारा आज ये ख़त्म हुआ। अब अगले क्लास में हम स्टार्ट करेंगे पी ब्लॉक एलिमेंट की कैरेक्टरिस्टिक्स स्टार्ट करेंगे और उसके इम्पॉर्टेंट एलिमेंट इम्पॉर्टेंट कंपाउंड्स के बारे में डिस्कस करेंगे।